In this video, I'd like to talk about finding the volume of rectangular prisms. So, what do we mean by volume, and what is a rectangular prism? So, volume, we can define that as essentially how much three-dimensional space an object takes up. So again, when talking about volume, we're talking about three-dimensional space, and we're talking about how much it actually occupies. So essentially, if you have this shape here, which this is a rectangular prism, how much space is on the inside of this shape? Remember, area is just looking at how much flat space something takes up, but volume is dealing with three dimensions. And there's a specific way to look at volume where we essentially want to figure out how many small cubes we can fit inside of our bigger shape. But before we get to that, let's think about what a rectangular prism is. So we can define that. Let me paste in a definition here. A rectangular prism is a solid three-dimensional object that has six faces that are each rectangles. And the second part is a little bit more confusing, but this is what makes it a prism. It has the same cross-section along a length. So what we mean by cross-section is that if you were to cut out a section in the middle, so maybe right in the middle of this shape, notice that we get the same rectangle we would get on the front. This is a rectangle that is 3 wide and 2 tall. So any rectangle we cut in the middle here would also be a 3 by 2 rectangle. And we could do that cross section really in any direction. So we could have done a cross section maybe across this way. And notice then, I'm not drawing this perfectly to scale, but you get a rough idea. But if we do this cross section, this has a length of 4 and a height of 2, or width or height. It doesn't really matter what we use for those words, but it's a 2 by 4 rectangle. And there's another way we can cut it as well. That if we cut it going up essentially along this direction, and again, I'm not drawing this perfectly, but you can get a rough idea of what we mean by cross section. This rectangle would be a 3 by 4 rectangle. So any cut we made going up, we could say, would also be a 3 by 4 rectangle. So one way to think about a prism is that if you take any of the bases, so maybe this front face here, we can call this the base, you can imagine sliding it all the way back to the back side of it, and it would slide perfectly through this shape. So that's generally true of prisms, and we'll look at other prisms in later videos, but any face we take, we could then slide that face through the prism here, and it would fit perfectly along the way, and it would end with the exact same face on the other side. And again, this is specifically for a rectangular prism. There are such things as triangular prisms, pentagonal prisms, and so on. You can have many different types of prisms, and they all have this property here where they have the same cross-section along a length. So we'll come back to that later, and for this video, again, we're trying to find the volume of this rectangular prism. So a specific type of rectangular prism is what we call a cube. So let me draw in a quick picture of a cube here. And a cube is going to have all of the same lengths on each side. So it's a specific type of rectangular prism where all of the side lengths are the same. So specifically for this video, we're going to look at what's called the unit cube. And with the unit cube, every side length will have length 1. So this is a 1 by 1 by 1 cube. And the idea of volume is to figure out how many of these can fit inside of the object. So this unit cube, we would say this has volume of 1 cubic unit. So the units for volume are going to be cubed, since essentially each side length will have 1 unit, and we're going to be dealing with multiplication. To find the volume of a cube, you're going to multiply each of these different side lengths together. We can call this the width, the length, and the height, or maybe it's better to call this the height and this the width and this the length. It doesn't really matter since you can rotate it. But we multiply those together, and you would multiply unit by unit by unit to get cubic units. So again, we're just trying to figure out how many of these unit cubes we can place inside of this rectangular prism. And eventually we'll come up with a formula, but for these problems, you can draw a picture to figure out what's going on. So it'll be very similar to how we dealt with area. We're going to take each of these rectangles and split them up into 1 unit side lengths. So for instance, this height here, notice it's the same as over here and here. This is a height of 2. And we're going to split this in half so that each of these lengths are now 1 unit long. Or in this case, we're dealing with centimeters. So these are each 1 centimeter long. And then we'll do the same thing for this width here of 3 centimeters. We're going to split this into 3 pieces. And we're going to repeat this process for each of these faces. And what you'll see is you end up with a bunch of cubes that can fit inside this, or specifically a bunch of unit cubes. So this rectangle here, we're going to again split this side into 2. And this one here will split into 4. So this one's going to be a little bit more difficult to draw perfectly since we're dealing with some perspective here. And then for the top face, notice it's 3 wide and 4 long. So we'll split this into 3 again, and we'll split this side into 4 again. Now notice that we split all of these side lengths into a length of 1 centimeter. So these are all 1 centimeter, these are all 1 centimeter. And what you can notice now is that you have a bunch of unit cubes. For instance, let's take this top right piece here. This is a unit cube. It's 1 by 1 by 1. It has 1 for the height, 1 for the width, and 1 for the length. And you can imagine that it does fill out on the inside there, but it's going to get messy if we draw that in for all of these. So at this point, you have a whole bunch of unit cubes, and you can count them up. So let's just start with this top piece, and then we'll essentially double it to get the bottom as well. So we have 1 there, 1 there, 1 there, so that's 3. And then we have 4 rows of these 3 unit cubes. So we get 3, then 6, 9, and then 12. So we have 12 of these unit cubes up top, and then there are essentially 2 rows of these 12 cubes. So 12 plus 12, that's 24. So the volume of this rectangular prism is 24, and we're going to deal with cubic centimeters. Because again, for each of these unit cubes, you have 1 centimeter by 1 centimeter by 1 centimeter. And to find the volume of a unit cube, you multiply height times length times width. So that would be 1, let me write this in, this is 1 cubic centimeter, just for this back right and on the top unit cube. Now, this process of splitting up our rectangular prism into a bunch of small unit cubes can be a little bit tedious, especially if the numbers are bigger. So what you want to notice is the pattern. That 24 cubic centimeters, this volume that we got by just counting up these unit cubes, can also be found by taking our length and multiplying it by our width, and then multiplying it by our height. And again, those words are really interchangeable. You could have called this the width, this the length, and this the height. But the main idea is that we multiplied the three different dimensions. We took our 2 centimeter height, we multiplied it, I guess we can call this the width, by the 3 centimeter width, and we multiplied that by this 4 centimeter length. And 2 times 3, that's 6, and 6 times 4, that is 24. So you still get the same answer, but this is the pattern that you want to notice. And we can generalize this pattern that the volume of a rectangular prism is going to be the product of the three dimensions. So it will be the height of the prism multiplied by the length of the prism multiplied by the width of the prism. And we could do this with letters. A lot of times you'll see height written as h, v for volume. So v is h times the length L multiplied by the width W. So you just need to remember you're just multiplying the three different dimensions together.